right, we can go ahead and get started. Thank you guys for coming to SoCon, for coming to our talk. Duane and I are going to talk about our research into SCCM attack path management and a new repository with a knowledge base that we've created to kind of catalog all of the tradecraft that's come out that we're aware of. So, quick introduction. I'm Chris Thompson. I'm a principal consultant on the adversary simulation team at SpecterOps. I do a lot of red teaming, pen tests, research, development, tool development, stuff like that.
Hey, good morning, everyone. My name is Duane Michael. I'm a adversary simulation operator, trainer, and manager at SpecterOps. Chris and I have presented on SCCM at Black Hat Arsenal and DEF CON Demo Labs. He didn't mention this, but he's the primary author of Sharp SCCM, and I helped him out with that a little bit. And then we wanted to give a introduction slide to Garrett Foster, who couldn't make it today, but Garrett has been instrumental in this SCCM research. He's been kind of forging the path on offensive SCCM tradecraft over the past couple years, and he's also instrumental in developing the Python-based tooling that we are using on operations all the time. Okay, so we'll start off with an agenda just to kind of set expectations for what this talk is and what it is not. So we want to expose you to some of the SCCM attack paths that we are seeing in real-world customer environments. So we're going to share some stories from the field, and then like Chris mentioned, we're going to introduce a knowledge base that kind of consolidates all the stuff that we've been seeing over the past couple years. This talk is not an in-depth technical talk. We are not going to walk through specific offensive techniques or tradecraft, so apologize if that's what you're here for. We're not going to do tool or attack demos, and we're not going to go super in the weeds on the topics that we discuss. With that said, we are going to introduce a platform that you can use to find all of those things and then some. Okay, so what is SCCM in the first place? So SCCM, also known as Microsoft Configuration Manager, that is the official name nowadays. It has changed names many times over the years, but you'll probably hear us refer to it as SCCM most commonly, which stands for System Center Configuration Manager. It's basically a platform used for deploying software and operating systems, managing software and operating systems, compliance settings, pretty much anything that you would want to manage on your endpoints. SCCM or Configuration Manager can do that. It is, like I mentioned, used for real-time management of all of these things. You can use it to deploy software. You can use it to boot new computers, boot operating systems, whatever. So if you are working on the offensive side, that probably sounds interesting to you, right? Like that sounds like we could probably use that to do some nefarious things. And so as an attacker, why should we care? Well, it's a Microsoft product. It is extremely widespread. It's used by many organizations. I would say probably most organizations that are Windows and Active Directory environments. So you're very likely to counter it on a pen test or a red team. It's also used to manage clients across Active Directory forests and networks. So segmentation or that forest Active Directory boundary isn't so important for SCCM. SCCM does not care about Active Directory. They are separate things, and so you can use it across domains, across forests, whatever. And it's commonly misconfigured, and this is due to some insecure defaults, which we're going to talk about a little bit today. But like I said, we're going to point you in the direction of where you can find what a lot of those are, and then. This is a tool that systems administrators are using and have been using for a long time. So like if you Google how to do something in SCCM, you're probably going to find a Reddit thread or a blog post that's giving you very bad advice. And we have actually used that to kind of key us in on some possible attack paths. So what the stuff that's out there for sysadmins is not super secure. So as a defender or administrator, why should you care? Like I said, it's widespread in Windows and Active Directory environments. If you're working in an on-prem environment, you probably have SCCM deployed. So it's good to be aware of what is possible, what the attack surface is. And then these misconfigurations that we talk about can lead to very dangerous vulnerabilities. These can lead to domain compromise through seemingly, the misclicking a single button in the deployment of SCCM can lead to domain compromise. And so, this is kind of just the result of years of technical debt and these dangerous default configurations. And so this slide's really interesting. Credit to Karsten Sandker for this slide, who released it in a blog post of his. But it is very helpful to visualize kind of the evolution of not just SCCM, but also the attacks against SCCM. So it was first released back in 1994. There have been several releases over the last couple decades. And then in 2012, I believe, at DEF CON 20, Dave Kennedy and Dave DeSimone presented about using SCCM. If you can compromise SCCM, how you can use that to further your post-exploitation. And then over the next couple years, there were a couple blogs about using SCCM as a defender, as an incident responder, because it has such rich information sources. And then a couple years later, 2015, 2016 timeframe, our coworker Matt Nelson released some research on it about using SCCM to further post-exploitation activities, and he released a tool called Power SCCM. But that was early 2016, and ever since, it's been kind of dormant. There hasn't been much research that has come out since then, until you see this uptick in 2022, which is when Chris and I first released our blogs, and then a bunch of other people in the community have also released really interesting research, kind of building on the foundations laid by those before us. So it has definitely picked up in the past couple years, and there's still a lot more work to do.
Before we dive into the types of attack paths that we've seen in real-world environments, just want to quickly talk about some terms that we're going to use in the SCCM environment. So a hierarchy is like one instance of SCCM. Think an Active Directory forest. It is the entire installation of SCCM. Hierarchies will contain different sites, and that is like a container for management of a scope of client devices in that site. So you might have different sites for different geographic regions, things like that are all inside one hierarchy. And when we say client, we just mean a device that is being managed by SCCM. It receives content from the site. Maybe it's software updates or scripts to run or programs to install. So there are a few different kinds of sites. The main one that we're going to deal with is a primary site. That is the type of site that clients are actually joined to. There is also a central administration site, which basically manages multiple primary sites. So you might have a central administration site managing all of your primary sites for the different geographic regions. And there are also secondary sites, which are more for like remote satellite offices that have low bandwidth. And you can have multiple secondary sites under a primary site. The primary site server is the controller for SCCM. There's one for each site and one for the central site if you have one. Confusingly, it can be referred to as just the site server, and other roles in SCCM are called site systems. So very difficult to refer to these, but we're going to call it the site server for most of this talk. And the site database server is where all of the information about client devices in SCCM is stored. A quick example of what this might look like. So at the top level of the hierarchy, we have a central administration site. We have multiple primary sites under the central administration site, and then we have multiple secondary sites, or client computers can just communicate directly with a primary site. So basically the takeaway from this slide is it can be very complex. It can grow into a massive hierarchy that can be difficult to manage. And a lot of times, since SCCM has been around since 1994, this has passed hands a bunch of times. Things get messed up. And just get overlooked after a period of time. So SMS provider is a site system role in SCCM that allows interaction with the database. So the primary means of using SCCM as an administrator is the SCCM console, the configuration manager console. It's software. That software communicates with an SMS provider, which then communicates with the database. But the console is just a GUI application. It provides front-end access to all the functionality in SCCM. This is how SCCM servers communicate with one another, as well as how clients in the configuration manager, the config manager console communicate with site servers. I'm not going to explain this entire slide. You can check out the repo later if you want to learn more about these protocols, but basically there's an enormous attack surface here and a lot of different communication protocols between each of these systems, and because of the way they authenticate to each other, we can abuse this.
Okay, so SCCM uses a lot of different accounts to do a lot of different things. This is kind of, we'll get into this a little bit more in the coming slides, but this is kind of the crux of where some of the most simple and most commonly abused misconfigurations come from. So on this slide, we talk about just a couple of the different types of accounts that SCCM uses. So for example, we have a client push installation account, which is used to install the SCCM client software on computers. This account must be an admin on the computer that it wants to install the client on. So that sounds interesting, right? And so we see a lot of overprivileged scenarios with this account. The most common account that we see misconfigured is the network access account. This account is just used for reading software from a distribution point. In the most basic SCCM scenario, it is an optional account. It is you're not supposed to use it anymore, according to Microsoft, unless you meet a few specific scenarios. And the credentials for this account get stored on every client and protected via DP API. But we can also spoof a client and request a policy and deobfuscate that policy before it even gets encrypted on the client. And then here we mentioned task sequence because task sequences, which are as the name implies, a sequence of steps that you can run on an SCCM client. There's lots of different accounts that are used in that process. And so one of them is called a domain join account, which is used for when you boot an operating system from during a task sequence, and you want to join that new computer to the domain join account will be used. There's a run as account, which is used to run as in a different context. Network folder connection account, and there's 29 different accounts listed on this link at the bottom, which is the official Microsoft documentation for how to deploy SCCM. 29 different accounts. So if you're a fresh green sysadmin that's deploying this for the first time, you might just be inclined to use a domain admin account for everything. Okay, so I mentioned the client push installation account. And this is used client push installation account, but here we're going to talk about the process of client push installation on its own. And so client push installation is how we can push out that SCCM client to computers in order to install that client software on the computer. To do this, we have to have administrative privileges over that target computer, and we will copy installation files to the admin share on that computer, and then execute the client installer, which is called ccmsetup.exe. And then, like I mentioned, this will use the client push installation account if it is configured. If that is not configured, then it will use the site server's computer account. So either way, you have some privileged context, some privileged system or account authenticating to you. Okay, so that's client push installation in a nutshell, but there's a few different ways that you can configure client push installation. One of which is called automatic site-wide client push installation. And you guessed it, this is to install that client automatically as new systems are discovered. So SCCM has a bunch of different discovery methods for how it can find new systems out there on the network. This can be things like Active Directory groups, network, like a subnet or whatever. So lots of different options. When the site server finds that new computer that it wants to create or make a client, the site server will attempt to automatically authenticate either with its computer account or with that client push installation account, and attempt to go through that process of installing the SCCM client software. So we can abuse this by spoofing a device record, and we can coerce that authentication from either the site server or the client push installation account. And so if we can coerce that authentication, then we're receiving incoming NTLM authentication, which if you've been following all the different NTLM relay attacks in the industry in the past couple of years, this is just another way, another petit patam, if you will, that we can then relay off to some other system. So the next account that we'll talk about is the network access account. So this one is pretty interesting. It's a domain account that is simply used to connect to a distribution point to retrieve software. That's it. So it should be very low privileged. It should not have interactive logon rights. It should not be an admin on anything. Should. It's mostly optional. Like in the most basic types of SCCM deployments, this is an optional account, but there are a few scenarios where it is required. So, before going and disabling this, make sure that you don't meet any of those requirements, which we documented in the project that we're going to talk about later. All right, and so the network access account is by far the most common misconfiguration that we see, and arguably the worst because it is so simple and it is so common. So the site server includes, when this is configured, the credentials are included in a computer policy, which is sent to every SCCM client, which means if you can privesc on that client, you can retrieve the system DP API key, decrypt this, and then you have the creds. So if those creds are privileged, you have potentially DA creds, domain admin creds, sitting out on every client in your network. We see that all the time. But we can also spoof a client enrollment. So if we can control a computer, we can also request this policy, which is not encrypted on the wire. It's only obfuscated, and we can simply deobfuscate that and grab the creds before it even gets encrypted on the client. So 2 scenarios there, and if we can spoof a computer, that means either privesking and using that system account, or simply creating a computer object in Active Directory, which is a default in AD. So as I kind of alluded to, there are so many different accounts, at least 29 different ones in SCCM, and so it's pretty common for the same God mode account to be used for everything, which includes using it for the network access account. And so we see overprivileged network access accounts all the time, and what that privilege is varies from environment to environment, but we see domain admin pretty commonly. We see SCCM admin, which gives us full control of the SCCM site, which will tell you a little bit about how we can abuse that. We find this all the time. And then just a last note on the network access account, just due to the way that WMI and the SIM repository on Windows works, these creds can persist even if you change them. So if you have network access account A that was a DA, and then you rotate that to a normal network access account, as you should, the DA creds can still persist in the SIM repository on Windows and be recoverable until the end of time, until that device no longer exists. So that's very dangerous. And then obviously in that scenario, you want to invalidate those credentials, change the password on that DA account that you were using, or disable the account in AD.
All right, so we're going to talk about how to take over an SCCM hierarchy next. Before we get into that, I'm going to do a very brief primer on NTLM Relay. If you want to learn in depth about how NTLM Relay works, please check out Elad's talk at 2 p.m. right here in Explore, upstairs in Arlington. But basically, an attacker suitably placed in the network between a client authenticating to a server can intercept NTLM authentication if that authentication is over NTLM, and relay it to another system, an unintended system, with the privileges of the authenticating client. So if we can intercept authentication via NTLM, we can forward it to another machine, and if that account has access to that machine, then we can access that machine on behalf of that user. There are a couple bugs that allow you to force a computer account to authenticate to an arbitrary IP address, like printer bug and petit patam. So these are won't fix vulnerabilities or non-vulnerabilities according to Microsoft that can really reliably be used to coerce authentication that we can then relay to other machines. And if that computer account is an admin on that second machine, then we can compromise that second machine. So to take over an SCCM hierarchy, what we're really talking about is gaining the full administrator role. That's the super user role in a site. And the site database that contains the credentials and roles for all the users in SCCM is replicated between all of the different primary sites and the central administration site. So if you compromise the database in any primary site, those changes that you make, if you add yourself to the full administrator role, will replicate to all of the other sites. So if you own one, you own them all. And why do we really care about this? Because SCCM runs with system-level privileges on every endpoint that is a client. So we can gain arbitrary command execution to any client that is online. We can do real-time querying of information on the system with features like CM Pivot. We can run PowerShell scripts on those systems. We can make software available to systems or unavailable. We can do really whatever we want. So the key concept to performing this takeover is that the primary site server's domain computer account is required to be a local admin on every other system that's hosting an SCCM role. So that includes the site database. It is a sysadmin on the database, so a DBA, and local admin on every other site system in SCCM, distribution points, management points, all the things. So if we can coerce authentication from this account, which we can do with won't fix issues like printer bug and petit patam, and relay that authentication to the other servers in the environment, we gain control of those servers. And if those servers allow us to make modifications like adding a user to full administrator, then we compromise the entire hierarchy. So a couple examples of these attack paths. We can coerce authentication from the primary site server or the SMS provider, which both have access to the database, relay it to the database via MS SQL or SMB, access the database, grant ourselves full admin. We can do the same to an SMS provider. We can relay to the SMS provider's admin service, to REST API, or to SMB, do the same thing, access the database on behalf of that server, and grant ourselves full administrator role. We've found a ton of these just because of the domain computer account has to be admin on all of them. There's a ton of different ways to take over site, and all of them are cataloged in our project.
Okay, so now we're gonna talk about some of the stories that, based on our experiences and some experiences from our colleagues in the industry, things that we're actually seeing. Everything that we're talking about here are real misconfigurations that have led to some kind of privilege escalation or domain compromise. So first, we'll talk about the perils of excess, a tale of unbridled access and forgotten accounts in SCCM. So here we're talking about that overprivileged network access account again. So this list is just some examples of the things that we've seen. So a common one is, not a common one yet. One of the ones that we found recently on an assessment was there was some Pixie boot media stored on a SharePoint, and we didn't really have any access. And so, other than standard user SharePoint, which had read privileges to this Pixie boot media, which was there for some reason. Why? I don't know, but it was, and it was not password protected or anything. And so we were able to use that to grab the policy containing the network access account, which we found to be local admin on every SCCM client. So from just having read access to some random SharePoint location, we were able to get admin access to every SCCM client. Okay, so a common one that we do see is the same account being configured for client push installation and the network access account. And this is understandable from an administrator's perspective, because in the SCCM console, when you configure these, they're kind of close to each other. They're in like the same configuration. So it's easy to just think that it's okay to use both accounts. And so we see the network access account being a local admin on every workstation fairly commonly, just because the client push installation account requires admin on every client. We have seen the network access account, I'm probably just going to say NAA from here on out, the NAA configured with domain admin, which, again, there's so many different accounts, so why not just use one account for everything, right? That makes perfect sense. But it's bad, so don't do that. So we see DA accounts all the time. We've also seen it where the NAA was not local admin on every client, but for some reason it was local admin on every SCCM site server, every server in that site. And then, like I alluded to earlier, the NAA can persist on disk after the account is changed. When you change from NAA1 to NAA2, NAA1 creds can persist on disk. And so we have seen that. So, even though people picked up on, this NAA is bad, I should not be using my DA account anymore, we've still gotten DA by going after that old account in the SIM repository. And then just two shout outs here to people on Twitter. Erica Zelik told us about a story where she popped an NAA account that was an admin to the ADFS servers. And so from there, you could go on to do things like Golden SAML or whatever. So then another one that's really interesting is from Rust LA. Hopefully I'm saying that right on Twitter. He dumped the NAA and found two different network access accounts configured, one for one domain and a second for a different domain. So this was domain admin for both, two different domain admin accounts for disparate domains on a single client. So if you're configuring NAAs to manage multiple domains, then those creds are going to be spread across all those different domains. And then we included a collage of a few other stories because there are just so many. And there's so many that we didn't even include here that we've seen over the past couple years. All right, so the next SCCM tale that we'll talk about is booting up to boss level, a domain controller's unexpected journey. And yes, ChatGPT helped with the titles. So this is when we're talking about the domain join account, when that account accidentally owns the domain. So like I mentioned earlier, the domain join account is a task sequence account that is used for booting an operating system. So if you're Pixie booting an operating system, this account will be used to join that client to the Active Directory domain. And then just by the way that Active Directory works and ownership in Active Directory, the account that joins a computer or creates a computer object in Active Directory will have ownership of that new computer. So when a domain join account creates a new computer through your legitimate software or operating system deployment, it will inherently have ownership of that new computer that it joined. And so this applies to workstations, servers, doesn't matter, any type of computer. And so if you use SCCM to image a server, and then that server gets promoted to domain controller, this domain join account will have ownership of that domain controller. And we've been finding this one a lot recently, where the domain join account was used to join every computer, and we're seeing hundreds of thousands of ownership edges in Bloodhound over this because of this domain join account having those ownership privileges, which kind of just persist. And so that's really scary because this account is pushed out via that task sequence. So if you can pixie boot, you can potentially grab this account and then go from just network access to domain admin. And then another pretty scary one that we've seen quite a bit is when you configure SCCM, there's a checkbox where you can choose to enroll domain controllers as SCCM clients. And so this is, as you imagine, bad because if the domain controller is an SCCM client, then if you control SCCM, you can get remote code execution on the domain controller and do whatever you want on it. So, a few options for that. You can do application deployment, package or script deployment, just something to get codecs on that domain controller. So, like I said, this is a setting in there that you can just click the box to manage domain controllers or not, but we have been seeing this quite a bit.
So the first time we executed code on a domain controller like this, one of our coworkers found a connection string in a script on a network share that was referenced by a log file on an SCCM client that allowed us to authenticate to some random SQL database. That database didn't have anything useful in it at all, but it happened to be linked to another database that was linked to another database that was linked to another database, and that third link had DBA privileges over the central administration site database. So that allowed us to dump and crack DBA creds, which happen to be shared by all of the databases in this particular organization. And that allowed us to just connect to the site database directly with MS SQL, grant ourselves full admin, and with those admin privileges, we were able to install an application on the domain controller via the SCCM client that its installation path was a C2 payload that we had hosted on a public file share. This was completely undetected until we basically tried to become detected once we had access to this domain controller, so it was pretty cool, pretty stealthy attack path. This one was one that Philip Dragovich, sorry if I mispronounced that, told us about. So they were operating from a VPN client that was a client of SCCM. They saw that web client, so like WebDAV services were installed on the SCCM site server, which is not a default for Windows servers. Because they were on the VPN, they couldn't receive that traffic back from the site server after coercion. So they hosted a WebDAV server on the internet, created a DNS record for it, coerced authentication from the site server via web client, routed that authentication to their box on the internet, and then back through a tunnel to LDAP to conduct resource-based constrained delegation and take over the site server. So that was a pretty interesting one as well. This is one of my favorites. This was interesting. We were operating at a client and saw in their logs that automatic client push installation was enabled for their domain, and the site server had been attempting to authenticate to the CISO's laptop for over 2 years. We did not abuse this during the engagement, but there are a couple ways we thought of that could potentially be used to abuse this if we were to create a DNS record for that computer name and assign ourselves that IP address. Potentially, we could capture and relay that authentication. We just thought it was interesting that the site server was spraying its creds for over 2 years, not just to their laptop, but to a few others as well.
All right, so hopefully by now you see that there's a lot of different attack paths and a lot of different misconfigurations and a lot of different ways that we as red teamers can abuse SCCM. Over the past couple years, we've released a lot of blogs. The community has also released a lot of blogs, and I have felt overwhelmed with just keeping up with all of the all the different research coming out. Very hard to keep up with. And so we wanted to create a project, a repository, where we could just put all of this in a single location for people to reference. And so with that, that's kind of where the name of our talk comes from. We're introducing a project called Misconfiguration Manager. And the goal here is to help you manage these SCCM attack paths. And so, our coworkers, Will Schroeder, Lee Christensen, a couple years ago released the certified pre-owned white paper. I'm sure a lot of you have seen it or are at least familiar with the ADCS research. They told us that white papers are maybe not the best way to go. We felt that this was a white paper situation because there's just so much out there. But rather than doing a white paper, we wanted to go with a living knowledge base that we could continuously update and have the community contribute to as well. So kind of in the same spirit, we wanted to just put all of this out there in a single place for you to reference for both offense and defense. So this contains foundational information, so all the different site roles, sites, terminology, all that stuff, all that SCCM language that we've been using is contained within this, just to kind of give you that foundation. And then we go through and talk about offensive techniques, defensive guidance for most of the known techniques right now. And then we introduce a taxonomy and a lexicon to simplify and demystify some of these concepts. And then the project itself is based on MITRE ATT&CK, and we took a lot of inspiration from the Push Security SaaS attacks matrix, which is super helpful, really cool project. If you haven't seen that and you're in a SaaS environment, recommend checking that out. So this is just an example of what this looks like broken out into a table like MITRE ATT&CK. Across the top we have all the different MITRE ATT&CK tactics, minus a few that we didn't feel were important at this part, at this phase. But these are all the techniques that we have documented in this project so far, and there's still a few that we have not added to the project just because there's so much new stuff coming out all the time. And so you can access this project. It's on GitHub now. It's live, misconfigurationmanager.com, and that will redirect you to the GitHub repo. Okay, so I mentioned a taxonomy and a lexicon, and we felt that this was super important because we found ourselves talking about this stuff, and we're like, wait, you took over the site? Like, which takeover did you use? Like, how did you do it? And when you're trying to just have a conversation, saying something like hierarchy takeover via NTLM coercion and relay to MS SQL on the remote site database doesn't exactly roll off the tongue. So that's where this lexicon came from. And so as of right now, we have 5 offensive technique categories. They are CRED, Elevate, Exec, and Recon. And so as you can imagine, CRED is anything that is used for credential access, different ways that we can get credentials in the SCCM environment. And then each one of these numbers under the category would be like CRED 1, CRED 2, et cetera. And then Elevate are privilege escalation primitives that we can use to escalate either locally or on the domain, but not necessarily a full site takeover. We have Exec, which is executing code on a remote system through SCCM, so things like application deployment or script deployment. There are a couple more that we have not put in the repo yet, so we're looking for contributors. And then Recon. Recon is kind of a catch-all for both enumerating and performing recon on SCCM itself, finding where these systems are, but also using SCCM to perform that recon.
In case you were waiting for category number 5 to drop, it's takeover. Here are the takeover primitives that we have seen. And I added a 9th one recently for the SQL link crawling that we just talked about as well, since we wrote this slide. We're adding new stuff to this all of the time. The two of us and Garrett have been experimenting in the lab with different ways to do this. So this has been really useful on engagements. There's a ton of different ways to do this because of that admin privilege that the site server has over the other computers in the environment. Also included in the repo are prevention and detection measures that you can take for each of the attack techniques. and they all kind of like refer back to each other, so it's easy to jump around between them and understand, I conducted this attack, what recommendations do I need to make in order to defend against these attacks? And then there's a canary category as well for ways you can set up high fidelity detections by doing things like creating fake network access accounts that are pushed to every client. Maybe the credentials aren't valid anywhere, but if that account is used at all, you know that someone has pulled it and attempted to authenticate. So this is what the repo is organized like. We have the different attack technique categories on the left. Each of the attack techniques is numbered. The takeovers are numbered in descending, in order of what we think is the likelihood that you'll see these out in the real world. The other categories, cred, elevate, exec, recon, are numbered in no particular order. And then on the right, this is what each of the attack techniques looks like in the repo. So we have like brief description, the MITRE attack TTPs that it ties back to, the requirements for conducting the attack. So what criteria does the target need to meet in order to actually do this? We have a summary, impact, the defensive IDs that the attack technique correlates to, any sub-techniques. So a lot of the takeovers have different hosts that you can coerce authentication from to perform. And then very detailed examples, like walk through step by step of how to conduct an example attack for each of these techniques. And then a few references for each to external documentation that either informed how we created this documentation or is like an official source like Microsoft for why these configurations exist. On the defensive side, our defensive techniques contain, description, summary. We try and include background information for how to actually like understand at a deeper level, like why this is occurring, and then other defensive IDs that are associated with this particular defensive ID, and then what attack techniques it helps mitigate or detect. So there's a ton in there that we put in there, but we know there's more stuff out there that we would really like to see added. So if you have any ideas, or if you've seen other offensive or defensive techniques be successful for attack path management in an SCCM environment, please reach out to us. We hang out in the SCCM channel on the Bloodhound Gang Slack. There's an invite link there if you're not a member already. If you want to submit a pull request for a new technique, definitely welcome to do that. We encourage it. Or just, if you're not sure something has been validated quite enough, we have way too many labs set up. So if you want us to try something out for you, we're happy to do that as well. So that's all we've got for you today, but want to give everybody, a chance to ask any questions, and if there's anything we can help clarify further, we'd love to do that.
Sure, I'll go. I don't know if it's a good question. Just put it that
I'm sure it will be.
Do you find that the SCCM server is often, because I know you had mentioned that previously, like it's sort of its own separate thing from AD. Do you find that often it's its own standalone server? Do you find it often domain joined, or is it sometimes run as like on the same server as other?
Yeah, so the question was, do we often see the site server, the primary site server installed as like a component of a server that has other things installed on it, and is it joined to Active Directory typically? So it has to be joined to Active Directory in order to function, so yes on that. Usually it's a standalone server where it doesn't host any functionality aside from SCCM, but a single server can host a bunch of different roles in SCCM. So in a smaller environment, you might see a primary site server that is also a management point that clients contact for policy, and also a distribution point where they pull software from. You can host a bunch of different roles on the same server, and because you can't relay authentication back to the server that you coerced it from, hosting things on the same server can prevent a lot of these attacks. Good question. Any other questions?
If you assume that all of these configurations are fixed and I have a program configured SCCM, do you see sites as a kind of security boundary? So I have one site for secure clients, I have one site for less secure clients where they share primary site and database.
Gotcha. So the question was, if you've configured everything else correctly and securely, and you have used sites as a security boundary to separate clients of a different security level from those of another, is that sufficient? And the answer is no, because the site database is replicated between all of the sites. There is no security boundary between the different sites. The hierarchy is kind of a security boundary just because it's like the edge of the installation, but not really, because you can add accounts from multiple Active Directory forests. It can auto discover systems on the network level. Like if it sees a new subnet, it will just blast out credentials to try and install the client on that. There's a lot of ways that this can cross security boundaries that are unintended.
Yeah, so that's an interesting question because that's one of the things that we have been working on trying to properly articulate. So like we talked about the domain controllers, for example. How do you manage, what is the proper way to manage domain controllers with SCCM? Like it's a feature for a reason. So like what is the correct way to do that? And we typically talk about domain controllers being tier 0 assets. So if in that situation, if you're going to manage domain controllers, you'd have to also consider SCCM a tier 0 asset. But then as soon as it starts managing things that are below tier 0, it's no longer really tier 0, right? Because there are so many different ways that we can cross that threshold. So it's a good question. I don't think there's a perfect answer for it yet. So we just kind of say if something is secure, or like if it should be a security boundary, you probably shouldn't use SCCM across that security boundary. Any other questions? Yeah.
So for the domain join account, so every user within the Active Directory can join up to 10 domains that
Yep.
can be used to create, let's say, to join like up to 10 computers.
Right.
And they can pick also computer which can be used later on in, let's say, constrained workers
Yep.
delegation. So can I utilize this to join the group to create and do the NTM relays? Because I still can manage to have the right to the computer object within the Active Directory. So a standard user can help me in this case.
So I'm not sure I understand the question.
I think I might. So the question that you're asking, like, is the ability to add a domain computer account to the domain to fake a device record in SCCM enough to abuse any of these scenarios? Yes. Okay. So in that case, you can, if there's not like PKI certificates required for the clients to authenticate to their management point, which is not the default and is somewhat uncommon. Usually they use self-signed certificates. If that is the case, then you can create a domain computer account, use a self-signed certificate to register a device record with SCCM. SCCM will be like, oh, cool, new device. And if automatic client push is enabled, it will attempt to authenticate to that device with every single configured client push installation account, which that's gonna have local admin on workstations usually. And then it will follow that by authenticating with its computer account, which it's over SMB, so there's some cross protocol relay considerations there. But if that account is admin on another machine, then you could relay it there, and you know that account is admin on all of the other site systems in the SCCM hierarchy, and it has sysadmin access to the database. So if those are hosted on different systems, then that's a way to abuse that.
And then you can also use that if you have the default machine account quota set to whatever 10, anything above 0, you can also use that to spoof the policy request for that network access account. So you can use that to request the policy and deobfuscate that without having to worry about the encryption on the client. Does that answer the question? Okay, I saw. Yeah. Can you repeat that? He heard it, but somehow I didn't, and I'm closer.
Like, how easy or difficult is it to kind of get some enumeration of where all the different components live
Okay.
and what servers are they on and that kind of stuff?
Okay, the question is, how do we enumerate all these different site roles and components of SCCM? Is that right? Okay, so that's been a problem that we've been kind of working on. Our colleague Garrett Foster has done a lot of cool work. There are some LDAP objects that are created for this stuff, so we can enumerate some of it through LDAP. Others, we don't have the answers yet, but we're always looking for that because that is one of the hardest problems. You have anything to add to that?
So a couple other ways that you can enumerate these that Garrett's been working on is SMB. So a lot of the different site system roles will create new shared directories that you can enumerate remotely via SMB. And for the SMS provider, that provides like that REST API. So it's going to have certain HTTPS endpoints available that will respond to messages and indicate that they're an SMS provider. The site database is a tricky one. There's no information about it in Active Directory or on the SCCM client that we're aware of. So that one's a little tougher. Like you basically have to like look through accounts in Active Directory for SPNs indicating by their naming convention that they might be the site database, or maybe they're similar to other SCCM site systems that you've seen through enumeration. The best way to do that is with SCCM Hunter that Garrett wrote, and examples of that are in the recon category in Misconfiguration Manager. Yeah, maybe one more question if anybody has anything else. We're also, going to be around all week, so if you have any other questions, you can come find us. Awesome. Well, thank you all for coming. Really appreciate it. If you have any questions, again, please reach out to us. We'd love to chat with you.